All right, let's get started on a full lesson on protein. Now, this is the one I've been waiting for. Why I've been waiting for this one is that protein is like the cool person that once you get them to get to know them, they're not really that cool. Like, I don't understand why people are so focused on protein. I do get certain concerns, I do get certain ideas, but I want to try to break it down for you step by step to show you, yes, protein's important, but it's not that important for at least performance and competition. So the first thing I want to go through is how is protein metabolized by the human body? Just some basics, not a full physiology, but just so you can get a better idea of what some terms mean and why they're used kind of in the literature. So protein metabolism, meaning protein breakdown. Protein is consumed by mouth during a meal, a snack, whatever it is, something that you're eating. And then the bigger protein molecule is broken down into smaller molecules called polypeptides. So there's acids in your mouth, in your stomach, in your intestine that break down this protein into smaller little chunks. Then those polypeptides are broken down into smaller peptides that are called amino acids. Now those amino acids are then absorbed into the bloodstream. So you have the small peptides, amino acids that are absorbed into the bloodstream. So that's how protein gets into the body, into the bloodstream. Now, those amino acids are primarily taken to the liver to be processed. So the liver's like the quarterback. It brings in the play and it distributes wherever those amino acids should be going. So whether that's for recovery, repair, making new hair, making whatever structures that you can think of, enzymes, those are all of the things that the amino acids are being used for, hormones, etc. Now, particularly, there is a nitrogen attached to these amino acids. And that nitrogen is removed from the amino acids and is used to make new proteins, including muscle. So that's where that nitrogen comes into play. Now, there is one exception to this, and that is that branched chain amino acids don't necessarily have to go to the liver. They can go straight to your skeletal muscle to be used and metabolized there. That will come into play a little later when we talk about supplements. Now, you may hear someone talk about nitrogen balance. So nitrogen balance means basically if you have like a surplus or extra nitrogen, or if you don't have enough. Now, again, where that nitrogen comes off of is those amino acids that come from protein. And a positive nitrogen balance just is another way of saying you have a lot of these nitrogen ions around, and those can be used to make new proteins, specifically muscle growth. So positive nitrogen balance is achieved by having enough protein in your diet in order for it to be used for muscle. So that's the whole purpose of eating protein for muscle growth, is this positive nitrogen balance. Now, there's a couple key points that are very important in this situation. Unlike fat and carbohydrates, there is no significant store of protein in the body to be used for energy at another time. So, for example, fats are stored in fat cells, adipose tissue that can be broken down for energy. Carbohydrates can be stored in the muscle that can be utilized for energy. But proteins really aren't stored anywhere specifically to be used for energy for a long period of time. In fact, if you think about it, if you're using protein for energy, then there's not enough protein around to be used to build muscle. Now, that's the first point. The second point is, even if you're consuming adequate protein and you're in a positive nitrogen balance, muscle growth for performance does not occur without training. So think about this. If you're sitting on a couch, eating lots of protein, in a positive nitrogen balance, that doesn't mean you're going to automatically get muscle growth, because you have to have a stimulus. You have to have that strength training, that resistance training to stimulate the body to use that nitrogen in order to create new muscles. Or I guess I should say grow muscles. So what is an adequate amount of protein for a young athlete? So the protein requirement in general is about 1.2 to 1.7 grams per kilogram. Now, I've done a workup on many athletes. A lot of times these athletes are at 2.1, 2.3 grams per kilo of body weight. I wouldn't say it's harmful, it's just not necessary. That person doesn't need to be taking a protein supplement if they're that high. Now, this is also important. Despite the increased protein requirement, so that higher requirement, ballpark 1.5 grams per kilo, most athletes get enough protein throughout their daily diet. For example, 150-pound athlete, 80 kilograms, they would need about 105 grams of protein. Well, let's go through some of the examples. So, 4-ounce chicken breast, which most people eat more than 4 ounces, is 25 grams. A turkey club sandwich, black beans, all high levels of protein. Now, you're talking about a cup and a half of black beans already giving you almost 1/4 of the amount of protein that this athlete needed. It's easy to do. It's important that you start with food first. I'm not saying never supplement. I'm just saying think food first. Now, do you need to eat protein at a specific time? I will say there's a lot of recommendations out there. I've looked at the recent research. Really, it doesn't matter a whole lot, especially in our high school athletes. It just doesn't matter a whole lot. But I'll give some tips and some recommendations that are at least have some basis in logic, but at the end of the day, it may not matter too much. So, short answer is likely doesn't matter. As long as you're getting the proper amount of protein is usually what matters most. But there are a few examples that I want to share with you. So, casein and whey are two types of proteins that are both found in milk, but they have slightly different qualities. So casein is more slowly and evenly digested. Whey is more rapidly digested. Whey also contains quite a bit of these branched chain amino acids that I talked about can go straight to the skeletal muscle to be metabolized, to be utilized there. So what is suggested is that whey protein can be utilized around your workout, so pre or post or during your workout, whereas casein is utilized in the evening or overnight because it has this more slow, evenly digested quality that help it to be present throughout the whole night when growth hormone is peaking, whereas whey can really get into the system quite quickly, and that might be beneficial during a workout. Now remember, you're not using the protein for the energy to do the workout. You're having it available during the recovery process. It is also believed that leucine, which is a specific branched chain amino acids, can help stimulate protein synthesis. So sometimes people will advise to take that whey protein close to your workout or during your workout because it has leucine in it. You can also buy leucine on its own, and that could help to stimulate protein synthesis right in the vicinity of when you're doing the strength training. But honestly, it sounds like with the most recent research, if you take leucine even earlier in the day or just have it on board from having a good amount of protein in your diet, it usually is sufficient to get the job done as far as increasing your protein synthesis. As I mentioned, it can be helpful to consume a small amount of protein in that golden hour for recovery. So we talked about the carb to protein ratio being about 3-to-1. We talked about that's why chocolate milk was utilized because it's cold, but it does have a good amount of carbohydrate and about a 3-to-1 ratio of carbohydrate to protein. So that's another kind of strategy you can use as far as protein timing and recovery. All right. So those are my thoughts on protein. Those are my details that I want to share regarding why protein is useful, helpful for recovery, but it's not the end all be all when talking about performance and gaining an advantage in that way.